Today we are going to discuss exploratory data analysis, also known as EDA. When you start your project that involves machine learning, data science, analytics, AI solution, before starting to model that data using the algorithms, you need to understand the story in your data. So in this session, we are going to look at one example EDA, exploratory data analysis, using a public dataset available on US government website for around 40,000 different cars and their different attributes that describe their model, their number of cylinders, the year they were made, the manufacturer, and miles per gallon. In this kind of project, we always have a variable that we want to estimate or predict. Either it's a regression problem or classification. We are going to discuss if it's unsupervised learning problem where we don't have a dependent variable. Today, for the sake of this talk, we will limit our discussion to supervised learning. Before applying supervised learning, we need to understand the story in data. We need to understand what the variables are telling us about the problem. And this kind of analysis is the first step that you will go through and perform these activities on available decided data set that you have before moving on to modeling step. So EDA, what do I expect from you in this kind of analysis is given here in this example EDA that I prepared a long time ago for my students. The objective of EDA is to connect data with information and then extract some insight and knowledge from that. You start by having a summary of the data set in terms of how many rows are there and how many columns, variables, and instances or examples. So here we are looking at individual variables in terms of their distribution captured by 5 key statistics. Assuming that there is a barrels 08 variable, the summary of this variable will be described by min, max, mean, median, first and third quartile statistics. These 5 numbers tell us a story. They summarize. If there are 40,000 values, they are captured somehow and summarized by these 5 numbers. You can look at the range, minimum and maximum, and from min and max, you can have an idea of how this variable is going to behave in what range. At the same time, you can guess whether there can be some noisy values or not. For example, barrels 08, if it's a discrete variable, then minimum value being 0.06 will indicate that there are maybe some values that are noise or not actual correct values. At the same time, you will look at the mean value. If it falls in the middle of min and max, then you can roughly estimate that this variable has a normal distribution. You can confirm that normality by looking at first and third quartile as well. First and third quartile, if they seem to be in the middle of mean and max and min and mean, then the shape of the data will look like a mound shape, like a bell. So all the variables are summarized here using the 5 statistics related to that variable. Min, first quartile, median, mean, third quartile, and max. Actually 6 numbers, not 5. If your variable is not numeric but categorical, it contains values that are categories. For example, description of C240B description variable, it has different categories: 3.6 kilowatt charger, 6.6 kilowatt charger, 80 ampere dual charger, and some values that are unspecified. So this kind of categorical variable will be captured in terms of the frequency or the number of examples that fall in each category. So looking at this variable, you can see that the majority, 40,000 vehicles, don't have any description for this attribute. So immediately you can guess that this kind of attribute, which represents only a minority of the examples, very little minority, less than 60 out of 40,000, even though it's very little information, but it's discriminatory. It can help you identify some cars or some examples that have this variable not null. So all this numeric representation is very hard to go through and make sense of, but we need this as the first step of summarizing your data. In the next step, you will decide what variable shall represent my dependent variable, what I want to predict. So that variable, dependent variable, you will analyze individually. The behavior of dependent variable in this case is the uCity variable. uCity represents the miles per gallon, or how much a car consumes in terms of gas to travel n number of miles. uCity in this plot is represented using these small boxes. I will make it bigger. On x-axis, you can see year of manufacturing of the car is given. On y-axis, we have miles per gallon, or uCity. In each year, we group all cars that are made in that year. For example, 1990 has this box. Due to the shape of this plot, we are using boxes to represent data. This plot is called box and whiskers plot. Whiskers are these lines above and below this box. Box shows the same numbers that we looked at in the previous page: min, max, and median. The below line is min. Below line is first quartile, sorry. The top of the box is third quartile, and the thick line in the middle is median. All other points that we see as big dots above and below the box, these are the outliers. So we are here looking at individual years and the distribution of miles per gallon for all the 44,000 cars that we have in the data set. So here is a question. From this plot, what can we learn? First observation can be that over the years, last 40 years, the median miles per gallon for the cars is not improving much. It's almost constant, around 25 miles per gallon. But every year there are some manufacturers who are making exceptionally good cars that go way beyond the median. Those cars are represented as dots, the outliers. The third insight you can get is that after year like 1998, around 1998, there are some cars that started to pop up in the market, and they are doing exceptionally better in terms of miles per gallon. And after year 2012, even better cars are coming into the market, and some of them are doing 200 plus miles per gallon. So there is a new category of cars appearing here that are doing exceptionally good. What do you guess? What kind of cars are these? What kind of vehicles travel more than 200 miles per gallon?
Hybrid one.
Exactly. Electrical vehicles or hybrid ones. These are the ones that are going out of the normal course of the industry. So this plot summarizes the upcoming trends in data. And by only looking at the dependent variable with respect to years, you can identify. So this is similar job you will do with your own data. First, you will summarize whole data set in terms of the key statistics, and then you will pick the dependent variable and see its behavior with respect to other variables. We are going to refer to the other variables as independent variables. So here, the independent variable is year. In the next plot, we are not looking at uCity with respect to any other independent variable, but we are just plotting the distribution of uCity. And we can see that to the left of the histogram, majority of the cars fall here. Only very few cars are doing this kind of 100, 150 or 200 miles per gallon. That's why we have a long tail towards the right for the distribution. Now, even though these are minority cases, very few cars are doing this good, but they are showing some interesting and remarkable trend in industry. So we should look at them by zooming into the data. How do we do that? We subset. We look at only the cars where uCity is greater than 75. So we see that total 169 cars are doing more than 75 miles per gallon. When we look at their distribution with respect to fuel type variable, we see that only electric and hybrid cars are there. The other fuel types like CNG, gasoline, etc., there is no car from that category that is doing more than 75 miles per gallon. After zooming into the data and looking at the relationship with fuel type, then we can go further and check the detail of these 169 cars. Who is making them? We see that Ford, Dodge, Chevrolet, GMC are the makers. These are the models that are doing better than 75 miles. So you recognize any car that is on the streets and you see very often? Maybe Caravan, Dodge Caravan. You can go further to investigate the implications of dependent variable with the other variables and how it's behaving. Next, we will look at the independent variables. When we talk about independent variables, we can categorize them. They can be numeric or categorical. If they are numeric, then we look at them individually. ATV type variable is doing the behavior or distribution of ATV type over the years look like this. So after year 2000, FFV type of engine started to boom, and around 2013 they started to become less and less. So this trend came and went down. The diesel type engines started to decrease over the years, and after year 2000 there is a slight uptick in diesel type, etc., etc. So you are going to describe these insights in your summary of EDA. You can also box plot them with respect to uCity. If you box plot the vehicles, how do they look like over the years? Diesel engine, FFV, and there are going to be many NA values not available. So many cars who don't provide any information about ATV type, you can look at their behavior. These cars don't have ATV type, and their behavior with respect to dependent variable over the years is plotted here using box plot notation. In the same way, we look at number of barrels over the years individually, charge type, city, CO2, cylinders, displacement. For each variable, you provide their definition and your findings in terms of how they are related to other variables. One important aspect of EDA is to find out two variables that are strongly correlated. We do that using a special type of visualization. We call it correlation matrix. Correlation matrix looks like this. So we put On both x and y axis, we put the variables that we want to check the correlation for, and we see that U city is highly correlated with the city E and city 08U. The big blue colored circles represent positive correlation, and red colored circles would represent negative correlation. So city UF and U city are highly correlated. You can notice on the diagonal, all these values are maximally correlated. The value is 1, correlation value. Any reason why we have maximum correlation on the diagonal?
Because it is correlated to itself.
Because of self-correlation. Thank you. So you are going to prepare this correlogram or correlation plot to describe which variables are strongly correlated. In this issue of being strongly correlated to a pair of variables that are strongly correlated, they have some implications on your model. They can cause some trouble. And we refer to that trouble as collinearity problem. We will discuss how we resolve that problem, but to identify that problem, we use correlogram. We started with summary of the data set in terms of key statistics, and then we analyzed our dependent variable, and individually we treated each independent variable, looked at its distribution and relationship with other variables. If the independent variable is categorical, then you cannot do certain type of analysis on that. For example, you cannot calculate standard deviation, mean, etc. So what do? You look at this kind of behavior analysis using box plots. On y-axis we have year, on x-axis we have MPG data Y category. So we are looking at a trend going up over the years and then coming down. What do you understand from this plot? You are going to note it down in terms of your remarks for this particular variable. Another variable is maker of the cars. So you can see how car makers are behaving over the years. V class is another categorical variable. So most of the V class vehicles over 5,000 are compact cars, and least representative are these special purpose vehicles. So in your data set, most of the cars are compact cars and subcompact cars and mid-size cars. So categorical variables do give you very useful information about categories in your data set. This can help you decide whether to keep certain examples as key examples or useful examples, or you can discard them. For example, special purpose vehicle, vans, passenger vehicles, four-wheel drive. These are few cars and they can be treated separately. They need not to be part of the overall general model maybe. So you will decide based on this kind of visualization, you will know what are the important categories and what are the negligible categories. There will be some variables that you cannot put in the modeling phase. For example, car ID or engine ID is carries no predictive information. It's just an ID. If you use this kind of variable in your model, what is going to happen is not helpful for prediction. The model will just memorize the IDs of the cars and overfit on your data. This kind of variable, I refer to them as fixation variables. They cause fixation in model. Model get fixated on these variables and forget everything else. All other variables are useless. If you memorize and remember only this variable, you can do very good prediction in the training data. This is a pitfall because this kind of variable can cause huge prediction errors in test data. Engine description is another variable where you have most of the values as null. Engine ID, it's another index variable and it's not useful for prediction. So you will separate them out. At the end, you will summarize your insights in terms of what, from the information, what knowledge you gained and how that knowledge can be transferred to modeling phase. For example, in this data set, there are two contrast cases of vehicles, non-EV and electrical vehicles. So this gives you a choice to make a special model for non-EV vehicles and a separate model for electric vehicles. The median annual petroleum consumption is starting to decrease after 2010. A strong rise in dual fuel vehicles during 2000 and 2010 period, and then a sharp drop to the lowest. So this kind of finding can cause you to investigate more in the domain about the information that is not included in the data set. You need to go further from the data set and find the reason why this trend is happening. Is it real life trend or your data set is incomplete? If your data set has incomplete information, then it will lead to erroneous or biased model. So this kind of observation should be treated especially by going out of your data and looking into the domain knowledge to find out the reason for the trend, and so on. You will notice and make write specific paragraphs for your observations and insights into the summary module of your report. Your report will look like just like this example. You will include the numbers and plots and your commentary. You can include the code as well, but I will expect the code to be submitted separately. The code that you write for the report will be submitted separately, and the report itself will be a coherent document that you write and provide your commentary and remarks about your data set. So this far, we covered any example of EDA on structured data for supervised learning problems. In the upcoming sessions, I will be showing how you do the same for unstructured data. And in case you are doing unsupervised learning problems, how do you do your EDA over there? So let's take your questions.